So let's begin. This is a review for Calculus 1 Exam 2. This is using the UAB Calculus Test Bank. I have already taken this course, passed it with an A, and now I'm just doing a review to help people out. This is going to be on YouTube. If you see it and it helps you, good. If you have a question, leave a comment and I'll try and answer it. I literally have nothing else to do. All right. So first one, find the derivative of f of x equals tangent of x cubed. This is a chain rule problem. So we're just going to say, instead of f of x, we're going to have h of x is equal to f of g of x. Now, when you do the chain rule here, h prime is going to be equal to f prime of g of x times g prime of x. So now moving this over here to tangent of x cubed. First, we're going to do the derivative of the outside, which the derivative of tangent is secant squared. And this is still going to be of x cubed times derivative of the inside, which is going to be 3x squared. So your final answer, and this is f prime of x equal to this. So f prime of x is going to be equal to 3x squared secant squared of x cubed. That's a 2. So that's number 1 there. You got any questions, Miranda?
So after you multiply, you bring the 3x squared to the front.
Yeah, that's just how I like writing it. You can leave it like this. This is still correct. I just like having the x in front.
Alrighty.
It's more pleasing to my eyeballs. All right. So now scrolling down. Okay, so this is a chain rule with a quotient rule in it. And yeah, it's not fun. But anyway, the same principle as above. I'll redraw it real quick. H of x is equal to f of g of x. So h prime of x is equal to f prime of x, or g of x, times g prime of x. So coming over here, first thing we're going to do the outside. So f prime of x is equal to 4 times x plus 1 over x minus 1 to the third power times the derivative of the inside. X plus 1 over x minus 1. It's going to end up being... I'm going to do it over here because it's pretty big, actually. I'm going to do times a, and a is going to come down here. A is going to equal. So this is going to be x minus 1 times 1 minus. So basically, you got a derivative of the top times the bottom minus derivative of the bottom times the top. So it's just going to be 1 times x minus 1 minus 1 times x plus 1. That's all you have to do because derivative of x is 1. And that's a coefficient, so it goes to 0. So you don't have to worry about that. And this is going to be over x minus 1 squared. And this is going to give us... One second, Miranda. All right. So now that you've done that, this right here is the same as x minus 1 minus x minus 1. This is a plus here. Sorry. Plus. So this is negative 2 over x minus 1 squared. And all this is times 4, that is a 4, times x plus 1 over x minus 1 cubed. Now, what we can actually do is we can combine these. We got like terms on the bottom. So it's going to be negative 8, 2 times 4, times x plus 1 cubed over x minus 1 to the 5th, because we have it squared here, it's cubed here, so that's to the 5th. And this is going to equal f prime of x. Now, the actual quotient rule itself, you asked for that, didn't you, Miranda?
Yeah.
So the quotient rule is going to be, we're going to say derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. So derivative of the top times the bottom minus derivative of the bottom times the top divided by the bottom squared. And this is the quotient rule. And I can't spell quotient. That is quintet, but it's whatever. All right, moving on. Number 3, find the absolute maximum and minimum of the function f of x is equal to x cubed minus 12x on the interval -1 to 3. So the first thing we got to do is we're going to use the closed interval method. So by closed interval method. All right. So by closed interval method. So we're going to find the critical points. And these are the points where f prime of x is equal to 0. So first thing we got to do, we got to find f prime. It's going to be equal to 3x squared minus 12. The simple conversion from over here. X cubed minus 12x makes 3x squared minus 12. Then we're going to set it equal to 0. So we got 3x squared minus 12 equals 0. We're going to pull out a 3. X squared minus 4 equals 0. So x is equal to plus or minus 2. Now, the reason why it's plus or minus 2 is x squared equals 4. X is equal to square root of 4. And when you square something, it can be negative or positive. That is a 2. So now we have our points, but our interval is from -1 to 3. And the only one of these that is on the interval is positive 2. So -2 is eliminated. So now that we have our interval, we got x, we got f of x. Now we're going to find our absolute maxes and mins. So -1, 2, and 3. You only use the x values you found if they lie on the interval. And then all you do is you plug them back into the original equation. So f of -1 is going to be equal to -1 plus 12. It's going to equal 11. F of 2 is going to equal 8 minus 24, which is going to equal -16. Then f of 3 is going to equal 9 minus 36, which is going to equal negative, oh, my bad. That's cubed. Not squared, that's cubed. 27 minus 36, which is going to give us -9. So our values, we have 11, -16, -9. So absolute maximum is going to be at x. So max is at x equals -1, and the minimum is at x equals 2. And those are absolute maximums and minimums on the interval -1 to 3 using the closed interval method.
But you don't list the solution that we got, like 11 or -16 for the max and min.
No, that's only used to find which one is the absolute maximum. And the way you can say it is you can say that the absolute max is at x equals -1.
Okay.
So I'm just saying the absolute maximum are at x equals -1, and +2. The actual numbers are the maximum's 11 and the minimum's -16. But I'm just saying that it's at that point of x.
Okay.
You can do it either way. You can say that the absolute max is 11, absolute min is -16, or you can say that the absolute max is at x equals -1, absolute min is at x equals 2. Either way, it means the same thing. You're just writing it a little bit different. All right. And on number 4. Verify that the conditions of the mean value theorem hold. Next, find the number c which satisfies the conclusion of mean value theorem for the function f of x equals x cubed plus x on the interval 0 to 1. So the first thing of the mean value theorem is first thing, the function f of x is a polynomial. Therefore, one, f of x is continuous on the interval 0 to 1. And 2, f of x is differentiable on 0, 1. So now to prove that there. So we have our interval. We got 0, we got 1. I'm going to make this A and this one B. So our formula here is that, I'm popping my fingers. Ugh. Formula is that f prime of c, because this is the mean value theorem right here. So the next thing we have to do is find the value c which satisfies the mean value theorem. So we know that f of c is going to be equal to f of b minus f of a divided by b minus a. And this is what the f prime of c is equal to. So you plug in some values, you get f of 1, which is b, and that's going to be equal to 1 cubed plus 1, which is going to be 2. And then f of 0, which is going to be 0 because it's 0 cubed plus 0. And you plug in those values, you're going to get 2 minus 0 divided by 2 minus 0 equals 1. So that means that f prime of c must equal 1. Nope, never mind. Oops, almost did an oopsie. That's wrong. That's wrong there. Ignore that. You do not use the f of a and f of b values in here. It's b minus a. That's my fault. It's 1 minus 0, which means that f of c must equal to, f prime of c must equal 2. My bad there, for anyone who catches that. So now we actually have to find the formula for c. So f of c is equal to c cubed plus c. So now we got to find f prime of c, which is just going to be 3c squared plus 1. And now we set that equal to 0, or 2. Set equal to 2. So 3c squared plus 1 equals 2. 3c squared equals 1. C squared equals 1/3, which means that c is equal to this 1 over square root of 3. So c equals 1 square root of 3. And this is the value of C that satisfies the conclusion of the mean value theorem. Any questions?
So how come you worked it out? You did 3c squared plus 1 equals 2, and then you like kept going down with it?
What do you mean?
You went from 3c squared plus 1, then to 3c squared, then to c squared.
Oh, I'm solving this equation here. 3c squared plus 1 equals 2 right here. Then I subtracted 1, so I got 3c squared equals 1. And then I divided by 3, so I have c squared equals 1/3. Then I took the square root, and you get that c is equal to 1 over root 3.
Oh, okay.
So basically what it's saying is when it says to find the value c, first thing I did was I used this formula here to find what f prime of c is equal to. And it's equal to f of b minus f of a over b minus a. And I found that f prime of c must equal 2. Next, I plugged in c into the f of x equation and got c cubed plus c is the equation. So I took the derivative of that and got 3c squared plus 1. Then I set it equal to 2 and I solved for c. And that gives us the value of c that satisfies the conclusion of the mean value theorem, which is stated here. The function f of x is a polynomial, therefore f of x is continuous on 0, 1, and f of x is differentiable on 0, 1. And that's how you do that.
So if it was a polynomial, would the mean value theorem not hold?
But here's the thing, if you have it on a test, it's going to be a polynomial.
Okay.
Like they literally put it on the test so you can state this. Trust me, I looked at 7 different practice exams. All the ones that had it on here had something along the lines of this.
What does it mean to be differential on 0, 1?
You could take differentiable, you're able to take the derivative of it.
Okay.
You can take the derivative of it on that interval. Any other questions about this one?
Nope.
All right, moving on. Find the linearization of the function y equals f of x, which is equal to square root of x, at a equals 25, and use it to approximate the value 25.1 equals the root of 25.1. All right. So this one is the one we're going to do. We're going to solve this one by linear approximation. All right. So by linear approximation, we have that f of x is equal to f of a minus f prime of a times x minus a. So let's find some values, shall we? So first let's find, okay, so we have f of x is equal to the square root of x. We have that f of a, or well, my bad. Let me erase that. A is equal to 25. So f of 25 is just going to be equal to the square root of 25, which is equal to 5. F prime of x is going to be what, Miranda? That's the chain rule there. So we got x to the 1/2 here. Want the derivative of this, which is going to be equal to 1/2 root x. Do you know why that is, Miranda, there?
Yes, because you're left with the 1/2, and then when you're subtracting 1, it just brings it back to square root.
Yep, right here. You subtract 1 from 1/2, you get negative 1/2, so it's 1/2, or well, 1 over 2 times root x. So now the f prime of 25, or f prime of a, is going to be equal to 1 over 2 times the square root of 25, which is going to be equal to 1/10. So now we plug everything into our formula, and we get that f of x is equal to 5 minus 1/10 times x minus 25. Now it asks us to approximate the value of f of 25.1. So we plug that in, we get f of 25.1. And that's going to be equal to 5 minus 1 over 10 times 0.1. 25.1 minus 25, you get 0.1. So f of 25.1 gives us And I have fucked up my stuff over here because I missed it. It's actually plus. Can't make this up, man. How do I keep messing that up? How did I mess that up?
So the formula is adding, not subtracting.
Yeah, it's adding, not subtracting. So the answer is, I'm sorry about that.
Sorry.
F of 25.1 is equal to 5.01. That's the answer. And this is by linear approximation. All right, so like I said, sorry about that. It is addition, it's not subtraction. I accidentally copied it down wrong. All right, moving down. Number 6, find all critical numbers of the function y equals f of x, which is equal to the cubed root of x squared plus x. Now, critical numbers are where f prime of x equals 0 or does not exist. So it's going to be any points where f equals 0 or where or where it does not exist. So first thing we do is we have to take the derivative. And we're going to rewrite this to make it easier on us. All right, so f prime of x is going to equal 1/3 times x squared plus x to the 2/3 times 2x plus 1. We're going to keep this separate. We're going to work this one out. And this is negative, my bad, negative 2/3 here. So this is going to be 1/3 times the cubed root, or well, let's leave it how it is. It's not going to hurt anything. X squared plus x to the 2/3. And this is times 2x plus 1. So now we're going to set it equal to 0. Where is this going to be 0 or where is it going to not exist? Well, first thing we know, if this equals 0, then the whole thing equals 0. So 2x plus 1 equals 0. X equals -1/2. So we know that's one of our critical numbers. All right. And what is going to make this number down here 0? What's going to make x squared plus x equal to 0? So x squared plus x equals 0. Let's pull out an x. Get x plus 1. So we have x equals 0 and -1. So these are our critical numbers. And this is the critical number when f prime of x equals 0. And this is the critical number where f prime of x does not exist. And the reason why it does not exist for these two values is because you're dividing something by 0 and God cries when you do that. That's why we don't do it. At least that's how my professor told me.
So the -1 doesn't save it or anything?
Huh?
Just so I know the 0 would make it does not exist, but the fact that it also has -1 that wouldn't be a critical number.
Yes, it's x equals 0 and x equals -1. It's both of these. So I'll rewrite it. There you go. So critical numbers are x equals 0 and x equals -1. If you plug in -1 here, you get 1 minus 1, which is 0. Plug in 0 here, you get 0. And both of those make God cry.
Okay.
All right. Show that the equation has exactly one solution and how to find it. All right. Whew. Oh, this is by IVT, which it's been a minute since I've been in Cal 1, but I'm almost certain that's the intermediate value theorem. Is that what it is? Come on, Miranda, you're in this class currently.
I haven't seen this question before.
Okay, well, I guess it's a good thing here. So we're just going to solve this one by IVT, intermediate value theorem, I'm pretty sure. But the first thing you have to do is you have to make your statement. Here, our statement is f of x is a polynomial. A polynomial. Therefore, for comma 1 f of x is continuous everywhere. And number 2, f of x is differentiable everywhere. And we're going to rewrite this here. Continuous. All right, and it's really easy to prove that. Miranda, look at this equation. F of x equals x to the 9th plus 3 to the 5th plus x plus 3. At no number is this going to not exist. So therefore, it is continuous everywhere. And it is also going to be differentiable everywhere. But in following of this theorem, first thing we got to do is we got to take f of 0. And that's going to give us 0 plus 3 to the 5th plus 0 plus 3, which means that we have 3 to the 5th plus 3. And this is greater than 0. That's important. It has to be greater than 0 there. That's how you know it's going to be continuous. You have constants that even when x is 0, keep it above 0. So next thing we're going to do, we're going to take some big ass number. Trust me, this is part of the theorem. You take some big ass number and you plug it in there. And the reason why we're doing that, you take some big ass negative number, you plug it in there so it's less than 0. And then you can put an interval on there. And the reason why you're doing that, if this is greater than 0 and this is less than 0, then on that interval, somewhere in there, f of x is equal to 0, which means it has at least one solution. And if we plug this in, basically you get like negative 1,000 to the 9th plus 3 to the 5th minus 1,000 plus 3. And this is definitely less than 0. So, hold up, I gotta scroll down a little bit. Or, yeah, let's just, yep, select all that. Oh, God. Oh, Lord. Oh, what have I done? All right, let's just, yeah, there we go. All right, so now we have that so the interval is negative 1,000 to 0. And so our solution, number 1, by IVT, intermediate value theorem, there is some value, or there is some 0 for f of x on the interval negative 1,000, 0. Yeah, it's called intermediate value theorem because there's some intermediate value in there because you have a f of x of 0 is greater than 0, and then f of negative 1000 is less than 0. So somewhere in that giant interval, f of x equals 0. And I retract my earlier statement where I said this thing isn't going to equal 0 because, of course, it has to equal 0. I'm an idiot. Oh, no, I said it's not going to ever be, does not exist. Never mind. I retract my retracting statement.
Edit that out.
What?
Edit that out.
I'm not editing that out. They get to hear it. If they made it this far, they get to hear it. They earned it. All right, I'm going to clear it and do part 2. So the second part of the question asks, show that 2 distinct solutions is impossible. And here's how we can say it. We knew on that interval there was one solution on that interval. So here's why it can't be 2 solutions. Since f of x equals x 9th plus 3 to the 5th plus x plus 3, or, oh, my fault. Hold on. Since f prime of x is equal to x to the 9th plus 1 is greater than 0 and constantly increasing, it only crosses the x-axis once and it cannot take on more than one x value. Bada bing, bada bam. There it goes. All right, so like I was saying, it only crosses the x-axis once, so it cannot take on more than one x value. And just to help with that visual, I went ahead and graphed it on Desmos here. X to the 9th plus 1, you graph it. It only hits the x-axis once right there. And if it's negative, it's constantly decreasing. And if it's positive, it's constantly increasing. So it only touches that x-axis once, and there's no way for there to be more than one solution. Stop that. Leave that. Okay. There we go. Number 8. Oh boy, here we go. This is a fun one. I was actually the only person in my class who went up to the board to solve this problem, which is what we had to do back in my day, literally a year ago. So basically, you have to derive the formula for this equation. And let me tell you, it's fun. Or, well, you don't have to derive the formula. You have to backwards derive the formula. You got to find the height, the length, and the base. So let's begin. So first thing I'm going to do is I'm going to draw me a box. So I got me a box here. Right here. And we're going to say that this is an unfolded box. So when you fold all this up, it's going to make an open faced rectangular box. Now we're given some initial parameters. We're told here, rectangular box has volume 2 meters cubed and has minimal surface area. If one side of the base is twice as long as the second side of the base, state the dimensions of the box of minimal surface area. So here's our base, x and 2x. I know it kind of looks the same, but that's where we're assigning it. And this is going to be our h. So this is height. which means that this is x, this is 2x, this is x, that's 2x, and h remains the same throughout. So let us begin. So we're going to call this the bottom here. This is going to be bottom, and this is going to be side. So surface area of the bottom is going to be equal to length times width, so it's going to be 2x squared. Now, the surface area of the side is going to be equal to, let's see, we got x times h twice, and we have h times 2x twice. So we're going to have 2xh plus 2 times 2xh, or 2xh plus 4xh, or dear Lord, I'm writing it backwards and stuff. It's 6xh, and this is surface area of the side. So our surface area total is equal to 2x squared plus 6xh. And I know this is it's a little bit confusing and it's hard, but once you get to this part, you're good. If you're able to draw the picture, then it's real easy working backwards. Because all we have to do to solve here is we just have to get to the end and find out what x is equal to. Once we do that, we're set. So let's continue on. I'm going to pull it over here so I have more room. So now what we're going to do is we're going to replace h. And this is why. So we're given volume. Given volume is equal to 2x squared y. Do you know what y is, Miranda?
That would be a no.
Look right here. Height y. I labeled it as h because that helps me. But h is equal to y. So I'm going to make y h. And we're told that it's equal to 2. So now we have 2 is equal to 2x squared h. We need to know what h is so we can solve our other equation. It's our only unknown. So we're going to solve for h. We'll get that h is equal to 1 over x squared. We divide by 2x, 2's cancel, 1 over x squared. So now that we have that, we come back over here and we plug it in. So this is equal to 2x squared plus 6 over x. And the reason it's 6 over x is because x divided by x squared leaves you with 1x. So now we're at a point where we can take the derivative. And we have to take the derivative and set it equal to 0 so that we can solve for x. And that's going to give us our minimal surface area. So we're going to find surface area total prime, which is going to be equal to 4x plus or minus 6 over x squared. Set it equal to 0. And we get that 6 over x squared is equal to 4x. I need room. I'm going to erase this initial part here. We're going to bring it up here. So we're going to bring it up here. 6 over x squared equals 4x, which is equal to 6 equals 4x cubed. Divide, we get that x cubed is equal to 3/2. X is equal to the cubed root of 3 divided by 2. And that's what we're given as our x value there. Now, what we're told is the dimensions of it is base x, width 2x, and height y. And we figured out that the height is 1 over x squared. So you plug in this value, you get that our height is equal, you plug in the x here, height is equal to 1 over 3 root 3 over 2. This is squared. We get that our length, or x, straight x, is equal to just 3 root 3 halves. And finally, we get that our width, which is 2 times 3 root 3 halves. And there we go. That's that problem. Now, I think we got how many more? 1 or 2. All right, we got 2 more. So let's continue. All right, you get all that, Miranda?
Yep.
All right, going down. All right, I gotta zoom out a little bit for this one. So, use calculus to graph the function f of x is equal to x squared minus 4 over x squared minus 1. Now, what I'm going to do is I'm going to go ahead and actually graph it, and then I'm going to show you how. That's supposed to be a straight line at x equals 1 and x equals -1. I'm sorry. All my crap's wavy. All right, so there's our graph. It's crappily drawn, but basically you have x-intercepts at -2 and 2, y-intercept at 4. And you have holes or discontinuities at y equals 1 and x equals -1 and 1. And now to follow up. So let's go down, do some math. So in problem 10, indicate the x and y intercepts, vertical, horizontal asymptotes, increasing, decreasing, local, absolute, max, min, and all that jazz. So let's begin. All right, so number 1, I'm gonna go 1, 2, 3. Number 1, x and y intercepts. So we have f of x is equal to x squared minus 4 over x squared minus 1. So first thing we're going to do is we're going to do f of 0. This is going to give us our y-intercept if there is one. So we get 0 minus 4 over 0 minus 1. You get that 4 is your y-intercept. So y-intercept is equal to 4. Next, we have to find where x is equal to 0. So f of x equals 0. So x squared minus 4 over x squared minus 1 equals 0. So we get that x squared minus 4 equals 0. X equals plus or minus 2. And there's our x-intercept. So next, part 2, increasing, decreasing, all that fun stuff. So, or vertical, horizontal asymptotes, my bad. So since we have x squared minus 4 over x squared minus 1, x squared over x squared, it has the same power. So there's a horizontal asymptote at x equal or y equals 1. And the reason that is it's the coefficients. You got 1 over 1 here. So y equals 1 is a horizontal asymptote. For the vertical asymptotes, we find where this whole thing is going to not exist. So it's not going to exist when the bottom equals 0. So this equals 0, we find that it's going to equal 0 plus or minus 1. So that's our vertical asymptotes. All right, now for part 3. Miranda, can you see it good when I write over here?
Yes.
Okay. So what we're gonna do is we're gonna find f prime of x. Now it's really messy because it's a gross quotient rule. So I'm gonna simplify it a little bit here. You end up getting 2x times x squared minus 1 minus 2x squared minus 4 over x squared minus 1 squared. Okay. And it's messy a little bit, but remember, it's okay because I'm just going to do this. Negative 10x over x squared minus 1 squared. Now, what you end up having to do is you have to multiply it out, multiply that 2x out, everything. You end up getting 2x cubed minus 2x cubed plus 8x. Or my bad, minus 8x. 2x's will cancel out. Well, actually, hold up. Let me double check this. I did this a while back. Let me double check that real quick. So 2x cubed minus 2x minus 2x cubed. Oh, well, would you look at that? I actually messed up there. It should be plus 8x, which means that it should actually be, if it's plus 8x, that means that this number should be 6x, positive 6x. Sorry about that. But we take this value and we set it equal to 0 because we're trying to find where it's increasing, decreasing. So we take this and we set it equal to 0. We end up getting that 6x is equal to 0. We get that x is equal to 0. So since we have x is equal to 0, we make a little number line at 0. And we find, let's do, give me a number to the left, Miranda. Like negative 2?
Yeah.
So f prime of negative 2. And that's going to give us, what's that going to give us? So negative 2, that's going to give us, my head itches. Negative 2, negative 2 squared, 4 minus 1, positive, negative. So we end up getting, what the fuck if I cannot see today. Calculator, rescue me. Okay, yeah, simple head math. Dear Lord. Negative 12. I'm brain dead. 4 minus 1, 3, 3 squared, that's 9, is equal to negative 3. So to the left, it's decreasing, it's negative. Yeah.
Are you plugging into the derivative formula?
Yes, and now we're going to do one to the right of 0, f of 2. And that gives us, what does that give us? So if you plug in positive, my bad, to the right of 0, you plug in positive 2, you end up getting 12 over 9. It's the exact same thing, only it's positive. So this is positive. So we have that from negative infinity to 0. And this, I'm sorry, that's not a bracket. That's supposed to be a little thingy here. Negative infinity to 0. It's decreasing. And from 0 to infinity, it is increasing. And since we have these big old intervals, we get that the local max is at f of 0, which is 4, because you can't really take the absolute, something that's going to infinity. You can't really take a max value off of that. So we get that our local max equals 4. All right. So there's